Okay, 12.2, we're talking about angles and angle measure. So this is stuff that's going to be completely new on trig. You wouldn't have talked about this stuff in geometry. So a little bit of new information related to trig here today. So we have the standard position of an angle is when the vertex of the angle is at the origin and one ray is on the positive x-axis. So right here, this is showing the one ray on the positive x-axis and the other one over here. So these would be in standard position. So this is called the initial side, and this is called the terminal side. Okay, so that describes those here. Coterminal angles are angles that are in standard position with the same terminal side, so we'll look at that a little bit further down. A radian is another way to measure angles, and it's given in terms of pi. One complete revolution around a circle is 2 pi radians. And then we have a little formula for arc length as well on there. So this is a little basic unit circle that we're going to be looking at and using. And then we have a couple little formulas in here as well of how to convert from degrees to radians and radians to degrees. So first we're just going to start by drawing some angles. So we have one more thing to point out before we do that up here. We can have positive angles which go in a counterclockwise direction, and we can also have negative angles, which when you get into more advanced mathematics, a negative means more of a direction than it does, like, you can't measure something negative, you can't have a negative distance, but when we're talking about this stuff, this is a direction. So the negative means I'm going clockwise. So when I go back to here to draw these, all the way around a circle is 360 degrees, and it's divided up into 90-degree parts. So I'm going to draw my axis on here and then say, okay, this would be 90 degrees, this would be 180 degrees. If I went all the way down to the y-axis here again, that'd be 270, so I don't want to go that far, but it is going to be out here somewhere. So it doesn't have to be perfect, but that would be about a 210-degree angle. Okay, now negative 45. So negative means we're always starting on the positive x-axis. I'm going to go backwards or clockwise 45 degrees. So that would be halfway in between there. So this would be negative 45 degrees. Draw the arrow so you can see which direction they're going. Okay, so now if I go negative 430 degrees. So negative means I'm going to be going clockwise. So if I go one time around, that's 360 degrees. And then if I added a 90 onto that, that would be, what, 450? So I don't want to quite go that far. I'm going to stop about right here, and that's where my angle would be then. So it shows the direction that it's going, and that's where your angle would end up. So then 900 degrees would take us to where? So all the way around, one time around would be 360. And then another time around would be take us to 720. And then how much further around do we need to go? So positive direction is going counterclockwise, so we have, there's 360. Another time around would be 720 degrees. If I went to here, that's going to take me to 810, and then over to here, right on the x-axis, that is taking me to 900 degrees. So this is what a drawing of a 900-degree angle would look like on there. Okay, so example 2. Find an angle with a positive measure and an angle with a negative measure that are coterminal to each of these. So coterminal, our definition said angles in standard position with the same terminal side. So that just means that I can go around the circle as many times as I want and stop at that same location, and those would be coterminal angles. So on here, 210 degrees would be around, we already used that up here, so this is a visual of that, 210 degrees. Well, if I went around that circle again and added another 360 degrees, that would be a coterminal angle. So an easy way to do it is just to add and subtract 360 degrees, because that's one time around, to get a coterminal angle. So if I add 360 to this, that would give me 570 degrees. I could add 360 again if I wanted to. And 930 degrees would be one. But we want one positive and one negative angle, so here's a positive angle. The other way I can do it is subtract 360. So if I subtract 360, negative 150 would be another coterminal angle. And there's an infinite number of them. You can add or subtract 360 degrees on as many times as you want, and it'll give you all different coterminal angles. So same thing here, if I was at negative 120 and I added 360 onto that, that would take me to 240 degrees would be coterminal. Or if I did my negative 120 and subtracted 360, that would get me to negative 480. So there's two angles, one positive, one negative, that are coterminal. Okay, other side, a couple more. So we're going to switch them from radians to degrees or vice versa. So when you have degrees and you're going to radians, you're going to multiply by pi over 180. And we're going to leave the pi in the answer there. So when I do that, this is really the fraction 30 pi over 180, and then this part can get simplified. So 30 and 180, that's the same thing as 3/18, which is 1/6. So this is the same thing as 1/6 pi, which would be written as pi over 6. Now when we go the other way, and I want to go to degrees, I'm going to multiply by the reciprocal, by the 180 over pi. So now the pi's cancel out, and I have a 5 times a 180, and then divided by 3. So this would give me negative 300 degrees by doing negative 5 times 180 divided by 3. Okay, one more. So steering wheel of a monster truck has a radius of 11 inches. How far does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? So on the front page, we had this little formula where S is the arc length, R is the radius, and theta is the rotation in radians. So first we need to get what theta is. So we went 4/5 of a rotation, and one rotation in radians is 2 pi. 2 pi is one time around the circle. So if I do 4/5 times 2 pi, that gives me 8 pi over 5, and that's what I'm going to put in here for theta. My radius was 11. So then if I multiply that out, that gives me about 55.3 inches. And I'm using the pi button on the calculator for that because when we're talking about a real life thing, a distance, we don't want to have pi in the answer. We want to get a real answer there. Okay, so here's your last two to do. And for your joke, how do you cut the ocean in half? You use a seesaw. Okay, hope you have a lovely rest of your day and make sure you're kind to someone.